This is the 9th and final note of Unit 2 on quadratics. So this note will act as a bit of a review, but we will also be kind of finalizing that skill of graphing using this vertex form. So before, when we were graphing, we were using the step method. This is going to be very similar, but we're just going to focus it more on that vertex form. So before we get to that, we're just going to do a quadratic transformation review. So if we have a positive a value, the parabola is opening up and is vertically stretched. Okay, if we have a negative 1/2 a, so we have that negative out front, and we also have a fraction or a decimal, right? That can be turned into a decimal. The parabola is going to be reflected or flipped, right? Because of that negative, and because of that 1/2, it's going to be vertically compressed. Okay, moving on to h. If we have a negative h value, the parabola is going to be horizontally shifted to the right. Okay, and the reason it says wacky bracky here, all that is saying is that, remember, the h is what does the opposite thing, right? So even though it's a negative value and we would think negative would move left, it actually is going to move right. Okay, if we have a positive h value, on the other hand, we're going to be, again, we're moving horizontally, and we're going to shift to the left. Okay, so you just have to remember that that h makes it do kind of the opposite thing. Okay, moving on to our last parameter, it's k. So if we have a positive k, we're simply shifting up the y-axis. If we have a negative k, we're simply shifting down that y-axis. Okay, so again, those are vertical shifts. Okay, and then just a note that you should remember is that the vertex of the parabola is always going to be h, comma, k. Okay, so again, that's just a review of those transformations. So now let's look into actually graphing. So we have two examples here, and that is it. So parabola 1. So it's asking us to draw the graph of 2x plus 1 squared minus 8. So before we can actually graph that, we need to pull some information from this equation. So the first thing is the vertex. So remember, the vertex is h, comma, k, where h is always has the opposite sign. So I'm just going to underline. So this is our h, h and k. So although in the equation it appears as positive 1, the vertex is going to be negative 1, and the k value is going to stay the same. So negative 1, ugly 8. Negative 1, negative 8. Okay? The next piece is it's asking us, is the parabola opening up or down? So remember, as long as there's no negative out front, we're going to stay as opening up. And lastly, it's asking us for that step pattern. So remember, in order to determine the step pattern, we take that original step pattern of our base graph, which is y equals x squared, and our step pattern there we figured out was 1, 3, 5, and we simply multiply that by our a term. So in this case, our a term, I'll underline it there, is the 2. So we need to do 1 times 2 is 2. 3 times 2 is 6, and 5 times 2 is 10. Okay, so our step pattern is 2, 6, 10. Now that we have that information, we should know how to graph this parabola, okay, because this is based off of that step method that we looked at before. So the first thing we're going to do is plot our vertex, which is at negative 1, negative 8. So it's approximately right there. We know that we're opening up, so we are going to move up with our step pattern. Remember, the step pattern is always over 1 and then whatever your step pattern says. Over 1, whatever your step pattern says. Okay, so I'm going to go over 1, up 2, and put a point. From that new point, I'm going to go over 1, up 6, and put a point. And then if I had a larger scale here, I would go over 1 and up 10, but I don't. So I'm just going to go ahead and do the same thing on the other side. So over 1, up 2, over 1, up 6. Okay, so I have 5 solid points there. So all I need to do to finish graphing is connect these dots in a parabola shape, which will look something like that. Okay, so you can see we have that nice U shape there. Okay, we can also see, yep, it's opening up, so that's good. We must have graphed it right, and we must have plotted that vertex right because it is at -1, -8. Okay, so now looking at that graph, we can come up with some information here, right? So from the graph, we can tell, and this is kind of dating back to the earlier lessons of this unit, lessons 1 and 2. So the zeros, remember the zeros are the x-intercept, so where we're crossing this x-axis. Okay, so we're just looking to see where we're crossing. So I can see we are crossing at -3, so that point would be -3, 0. Right, on our y-axis, we're at 0. And our other point we're crossing is at 1, 0. Okay, and again, I just saw that from my graph. So I see I'm crossing here and I'm crossing here. So those are my zeros. Okay, the y-intercept is where we cross that y-axis. So that's this axis here, that up and down one. So I just look, where do I cross that line? Well, I can see a point here at -6. So that means my y-intercept is going to be 0, -6. Okay, and again, the x is 0, right? If we're on the y-axis, the x is always 0. If we're on the x-axis, the y is always 0. The optimal value, remember, is just your y-coordinate of that intercept. No. Your optimal value is your y-coordinate of your vertex, sorry. So your y-coordinate of your vertex is -8. I'm just going to zoom in here. So -8. And the axis of symmetry is your x-coordinate of your vertex, which was -1. And really we should say x equals that and y equals that. Okay, and that is simply, I'm just going to label here, is from your vertex, just as a reminder. Okay, so we're just going to do the same thing with parabola 2 here. So it says draw the graph of -x minus 3 squared plus 4. So again, from that equation, we're going to pull out some information. So first, we need to figure out the vertex, which is just hk. Remember, your h is going to appear opposite. So although it says -3, that x value is 3, or that h value is 3, and your k value keeps the same sign, so it is +4. This time our parabola is going to open down, and the reason I can tell that is because I have a negative out front, so that is going to flip it, right, or reflect it. My step pattern, remember, I'm just taking my original step pattern of 1, 3, 5 and multiplying it by my a value. Okay, my a value here is -1. Okay, although a 1 doesn't show up, when there's nothing there, we always assume it's 1. So all we have to do is multiply 1, 3, and 5 by -1, which is just going to make those negative, right? So we have -1, -3, -5. Now that we have that information, we are able to graph our parabola. So we're going to start by plotting our vertex. So our vertex was at +3, +4. So right there. Okay, now we're going to use our step pattern to graph our next points. Again, remember the step pattern is always over 1 and then do what it says. Over 1, do what it says. So in this case, we're going down, so we know we're going to have to go over 1, down 1. We can also tell that because there's negatives out front of those numbers, right? So I'm going to go over 1, down 1. From that point, I'm going to go over 1, down 3. And from that point, I'm going to go over 1, down 5. Okay, I'm going to do the same thing on the right-hand side. Over 1, down 1, over 1, down 3, over 1, down 5. Once I have those points, I'm simply going to connect them with our curved parabola line. Okay, so it will look something like that. Okay, and again, we can double check. Okay, yep, our vertex is in the right spot and it's opening down, so that makes sense. Okay, so that is the transformed function, right? Remember, our original function is just that base parabola that starts with our vertex at 0, 0. Okay, so these A, H, and K values have moved our graph, so it now appears like this. So from that graph, we need to figure out this information. So again, the zeros are just where we cross that x-intercept. So I can see that that is occurring at 1 and 5. So when I write those, it will be 1, 0, and 5, 0. Okay, so we have those coordinate points. The y-intercept is where I'm crossing that y-axis. So again, I just look, and I can see that point is at -5. So that coordinate is going to be 0, right? Because x is 0, y is -5. The optimal value, again, is that y-coordinate of the vertex. So I look to see where my vertex is. I go across. So my optimal value there is 4. So y equals 4. And my axis of symmetry, remember that would be the line that goes through this point. Okay, and I can see that that is occurring at x equals 3. So x equals 3. Okay, so we can get all of that information just by simply having the equation. Okay, so once we have the equation, we are able to graph, we're able to figure out what are the intercepts and what are the optimal value and the axis of symmetry. So this is the end of the last note from Unit 2.